In this video, I'm going to go through question number 4, which comes from the AQA specimen paper 2, higher tier. This question links to the topic on forces, and it also links, part of it also links to the energy topic, which is tested here as well. A student changed the force applied to a spring by adding weights. So this experiment is to do with Hooke's law. Okay. If you don't know what Hooke's law is, maybe make a note of it here. Figure 3 shows a graph of a results. So you've got the graph where you've got the force applied on the y-axis and the extension in centimeters on the x-axis. Write down the equation that links force applied and extension of a spring. You will find this equation in the equation sheet, which is force equals spring constant multiplied by the extension, or you could write F equals KE as a symbol equation. Identify the pattern as shown in figure 3. Explain your answer. So the pattern, because it's a straight line, right, through X, right, it's directly proportional. So when the force is 1, extension is 4. When the force is doubled, the extension is 8. So the pattern is extension of spring is directly proportional to the force applied. Because you're trying to explain, you need to give a reason. Because it is a straight line through the origin, right? That's a valid point to get the second mark, but it's not always going to be correct, right? If the line starts here and it actually winds up lower or higher than this, it's not directly proportional. It's proportional but not directly proportional. So remember, although we are not writing it here, make a note of it. When force doubled, extension also doubled. This has to be true for it to be directly proportional. Next question, give one way the student could improve her investigation. So how can you improve it? Because she's trying to find the relationship between the force and the extension. She can add more force. She's only added 3 newtons. She can go up some more, right? She's only going up in 0.5 newtons. Maybe she can actually go up in 0.1 as well. So those are 2 valid points that we can actually write down. So first point, test a greater range of load, in brackets example, up to, let's say, 10 Newton, right? Or she could also test more springs Next question, 4.4. Describe the relationship between work done and elastic potential energy. Now, if you look for the equation for work done, if I use the symbol W equals force multiplied by the distance moved, elastic potential energy E equals half K for spring constant E squared, which is the extension. Now, work done is also measured in joules. Elastic potential energy is also measured in joules. So, describe the relationship between work done and elastic potential energy in stretching a spring. The work done is equal to the elastic potential energy. So think about a spring. If you stretch a spring, let's say by 10 centimeters, you have to put in energy. That's your work done, which should be equal to the amount of energy that is stored in the spring when it is stretched, provided you are not losing any energy while doing so. Right? So describe the relation between work done and elastic potential energy in stretching a spring. The work done is equal to the elastic potential energy as long as the spring does not go past the limit of proportionality. What does that mean? Well, if you deform the spring, then you're not going to store the energy in the spring and it's not going to be equal to the work done. So if you look at a graph, right, as long as it's a straight line, the work done is equal to the elastic potential energy. At some point, the spring might deform, and the point at which it starts deforming is called the limit of proportionality. So, force and extension graph. 4.5. Draw a line on figure 3 to show the results of a stiffer spring. Explain the reason for the line you have drawn. If the spring is stiffer, then for a given force, it's not going to stretch as much, which means, so for when you apply a force of 1 Newton, let's say, because the spring is stiffer, it's not going to extend by the same amount. So for 1 Newton, it might only go up to 2 centimeters. Hold on, that would be wrong. So when it's 1 Newton force, the extension is 4. But for a stiffer spring, when the force is the same force, but the extension should be lower. So for when the force is 2 Newton, instead of it being, let's say, 8 centimeters, it is going to be, let's say, 6. So the line would actually be above the line that is already here. So it's not the perfect thing, so I would actually draw a line like that, right? Ignore that point, right? the gradient has to be bigger. Right? So explain the reason for the line you have drawn. Right? Right? So the line will have a greater gradient than the existing line. The reason a stiffer spring has a greater spring constant. Right? So if you rearrange the equation, K would become F over E. F is the Y value over the X value, which is the gradient. Oops, that's gone out of view. So a stiffer spring has a greater spring constant. So K, which is a spring constant, is equal to the F, which is the y-axis, divided by the extension, which is the x-axis. Y over x is equal to the gradient. Question 4.6. Explain what would happen to the spring if the student kept adding weights. So if you keep on adding weights, eventually the spring is going to get deformed. Right? So the spring will be deformed. Explain, you need to give a reason. Right? Because it would or has passed the elastic limit. Elastic limit is when it's reached the limit of proportionality, and after that it becomes inelastic. That is the end of question 4 on forces. I will see you in the next video. Thank you.